And welcome back. So this lesson is all about the sine law. So we've done two things with all right triangles, and you're probably thinking, hey Jen, not all triangles are perfect and not all triangles have 90 degrees. And you are right. So today we're going to look at what happens when you don't have a 90-degree angle. So one of the first things we're going to use is called the sine law. It is used to find unknown sides and angles in any triangle, but there's one condition that has to be met in order to use the sine law, and you're going to know it right away because you have to have an angle and the side that is across from it. If you do not have a triangle that has the angle and the side across from it, or you can't find the angle to go with the side across from it, you are not going to use the sine law. So it only works if you meet that condition. You have the angle on the opposite side. There are two different cases, I guess you could say, and in which we're going to use it, and I'm going to show you what the formula is. So the first one is you have an angle, the opposite side, and another angle. Now, what you're going to do, the formula for this is A over sine of A, so sine of that angle, is equal to, if we know them, in this case we don't, side B over sine of B, which is also equal to side C divided by sine of C. Okay, so this is true for all of those sides divided by the sine of their angles that are across from them. Okay, so A is across from side A, B is across from side B, and C is across from side C. Okay, the other case is when we're looking to find an unknown angle. And in this case, you would have an angle and its opposite. And then you might have another side, and you're looking to find this one. So when you're looking to find an angle, I always like to kind of take the angles and put them on the top. So in this case, I would do sine of A equals A, over A equals sine of B over B, and sine of C over C. So if I'm finding the side, I put the sides on top. If I'm finding an angle, I put the angle on top. So here, I'll finish that off. Okay, let's take a look at what we're going to do when we actually have an example or a problem. Okay, so moving down, let's look at this example. We're going to find the unknown side of the triangle. Now, you can see that the unknown side is up here. The very first thing I'm going to do, or step one in this case, kind of the same as before, is we're going to label the sides. Now, when I talk about this, I mean I'm going to label the sides that are across from all the angles with their little letter so everything can line up. So if this is angle T here, this would be side T. This is angle U, so this side is little u. And this is angle S, so this is S. That way everything lines up because, as you notice in the formula, A had to be over sine A. B was over sine B. So we want to make sure everything lines up. Now, the second step is to decide if we're actually going to use the sine law. And remember, we had to have an angle and the side opposite. So let's see what we have here. We have this angle here, 37, and it is across from a side that we know 4.6. So in that case, we can use the sine law. So we're good to go because we have that relationship. So once you've figured that out, you're going to actually set the formula up. So step 3, we're going to set it up. So here's how it goes. It doesn't matter what order you do it in, just that the letters line up. So in this case, I'm going to go u over sine u equals t over sine t. Oh, that's a big T. Equals s, little s, over sine, big S. Now, the one that we know everything about is the u's. And the other one that we're trying to find out, we know angle S, but we're trying to find S. So you can just use those two. We don't really need this one, so we can just drop it. Since we're not finding out anything for that. In some cases you'll use it, but not in this example. Okay, so let's plug in our values that we know. Plug in the values. So U is 4.6 meters over sine of 37. S is the one we're trying to find, over sine, and that angle is 82 degrees. Now, when we solve this, the reason I put it on top is because now it's really easy. All you're going to do is take the bottom of the one that you're trying to find and move it to the top. So this easily becomes 4.6 times sine 82 divided by sine 37. Now, if we calculate that on our calculators, 4.6 times sine 82 divided by sine of 37, we get an answer that says that S, I'm going to move it over here, S is equal to 7.6 meters when I've rounded. Not too difficult. All right, so let's look at another example. That one we were trying to find a side. So let's see what happens when we try to find an angle. So in this case, we're looking for angle A. Look at it again. How do we know that we're going to use the sine law? We have this relationship again. So because we have that relationship, I know I'm going to use the sine law. And also don't forget to label your sides. So across from angle A is side A. Across from angle C is side C. And across from B is B. Now, we don't need B because we don't know any of it. But again, let's set it up. But this time, because we're finding the angle, let's put the angles on the top. So in this case, I'm going to do sine 47, so that's the C, over 3.2 equals sine of A over 3.6. It's the length for that. Now again, the reason I put it on the top is because it makes it really easy. All you have to do is move this to the top and multiply. So let's do that. 3.6 times sine 47 divided by 3.2 equals sine of A. So all you have to do is multiply that out. So 3.6 times sine 47 divided by 3.2. And I get an answer that's 0.822773 equals sine A. And then all you have to do is do that sine negative so the inverse function on your calculator, or second function to find out what it is. And when I do that, I get approximately 55 degrees. So we found out that that missing angle was 55 degrees. All right, so this last example, a lot of people get to this one and they're like, oh, you tricked me. So I'm going to show you what happens in this typical tricked you example. So keep an eye out for these ones. Now, you'll notice that I don't right away have a relationship where I have an angle on the opposite side. So this one, I'm missing that side. That one, I'm missing that side. And that one, I don't know what the angle is. But be careful of these, because what was that one relationship I taught you about angles in a triangle? I said that angles add up to 180 degrees. Now, because we have two of the angles, this one and this one, we can easily, very easily find that third angle. So be careful of these ones. You're going to find the third angle. So third angle. So 180 minus 25 minus 80. And that's 75 degrees. So be careful of these, because they pop up and they try to trick you. Once you have that, now notice that we now have that relationship and we can finish our example. So I'm going to set this up. We're looking for this angle here. Let's label the sides. This is Q. This is P. This one is little r. And let's set it up. So we're looking for Q, so I'm going to put that on top. Q over sine Q, which is 25. And we know that R is 50 over sine of R, which we found to be 75 degrees. Okay, again, take this side, move it to the other side, and multiply. So Q equals 50 times sine 25, because we moved that sine 25 up, divided by sine 75. And then we just need to calculate it. 50 times sine 25 divided by sine of 75. And I get that this is 21.87, so I'm going to round that to 22 meters. And that, my friend, is the sine law.